Hello, Rainer, can you hear me?
Yes.
Okay, great. Yeah, sorry about that. Today I had to go for a bit of a meeting and it went a bit longer than usual.
Okay.
I hope I don't have problems in the future with Thursdays, but um, I'm actually not at home at the moment. I'm actually somewhere else just to host the lesson. So
Okay.
the screen looks a bit different. It's just the single screen instead of my usual other screen as well. So I'm just going to
Okay.
share the
Not a
screen.
problem. Okay.
The audio
Perfect.
might also not be as great, but I hope you can hear me and everything's all right.
No, it sounds fine on my side.
Okay, perfect. All right, so I'm
Yeah.
going to quickly go through the actual May June. So obviously you would have completed some of these questions. Your initial
Yes.
thoughts, easy, difficult?
Some of them difficult or just a bit misleading, and but eventually I was able to figure them out. And there were also, I think, one or two questions that were based on another one. So if you basically get the one wrong, you're going to get the other ones wrong as well.
Okay, so yeah, so that's actually really good in
Yeah.
terms of analysis and interpretation. If you're looking at lots of past papers, you should get a better idea of how they're actually testing the questions. So when you look at these past paper questions, obviously the focus is always to get 15 correct. So let's see how many of them you got right. I'm just going to run through them from 1 to the end. So I think there should be 30 questions approximately. And the objective is to get 15 right. So having done some of these ahead of time, maybe just mark the ones that you have done. So I'll do question 1 and then check the answer that you had gotten for your working. And if it's the same, then that's perfect. If you've got 15 out of
Okay.
30 correct, then we know you'll definitely pass this course. Then we just need to focus on getting your distinction.
Okay.
Okay, so suppose the cost of manufacturing 10 units of a product is 40. I'm actually going to bring this up and then just shrink it. At least then I can write as well while we read the question. Okay, so suppose the cost of manufacturing 10 units of a product is 40 Rand and the cost of manufacturing 20 units is 70. Okay, if the cost is linearly related to output in units, the cost of producing 35 items is. Okay, so here you've got X and Y basically. All right, when I look at this question, I can see I've got units, which is quantity, and I've got price. Okay, so you could give these variables if you wanted to. You don't have to, but I'm just labeling it Q and P. The first point in terms of units, 10 and 40. And then you've got 20 and 70. And then the giveaway here is the word linearly. So that means straight line. So obviously y2 minus y1, close bracket, open bracket, x2 minus x1 is going to give you the m. Remember, m is the gradient for a straight line, and that you need to determine having two separate points. So that you can actually work out using this. And then here they said, if the cost C is linearly related to the output Q, units produced, the cost of producing 30 items is. Right, so the question mark is, if I have the cost, which is the price, in other words, what is the cost? So the cost would be multiplied by the price. So you'd have to work out 35 items, question mark, what is the price going to be? All right, so you've got 10 and 40, you've got 20 and 70, and now obviously the question mark here is what is going to be if it's 35. All right, so you could use an equation if you want to, or depending on how good your ratios are, okay, this would be a ratio. So 10 to 4, 2 to 7, and then you'd have to get 35 to something else. Okay, so I'm going to use this just because of the mathematics, and we'll use P as the Y. So I'll have 70 minus 20 minus 40, and then I'll have 20 minus 10. So that gives me, in terms of an answer, undo. Okay, I need to press function actually using the keyboard. So just need to remember that. Okay, so equals, 70 minus 40 is 30. 30 divided by 10 is 3. So you've got m as 3. So you've got y equals mx plus c. Okay, obviously your y here would be 3x plus c. C you have to get using one of those 2 points.
Hello?
Hi Reno, sorry my connection dropped. The Wi-Fi here is not so great, but
Okay.
sorry about that. The connection. Okay, is the
No
screen
problem.
up?
Yeah, yes.
Okay, great. All right, we're back. Is this running? Oh, this is running. Okay, great. So I was looking at the y equals mx plus c just before the internet connection dropped. This is y equals 3x plus c. Obviously, I'm looking for the c, so I can put in any of those points. I'm just going to put in the first point. So use the 40, then I'll have 3 times 10, close brackets, plus c, and that's going to give me 30 minus the 40, so that's 10 equals c. Okay, so now you've got y equals mx plus c, and you've got an equation that looks like that. Right, so they said it's linear, so the cost is linear, and obviously looking at Q, which is the number of units. Right, so the C is the cost, and that's what you're looking at here. So if I use their variables, I can actually change this. This would have been, oh, yeah, that's fine. Q is the quantity, that should be a C instead of a P. And then obviously my independent variable would be my quantity. So that would be Q, and my dependent variable would be the cost. So obviously C equals 3Q plus 10. Right, so if I copy paste and I just complete, the Q is 35.
35, yeah.
Okay, and then the answer would then be $115. Did you get the same answer?
Yes.
Well done. Okay, question 2. Question 2 in terms of workings, here you've got, all right, 2, 3, and 4. Okay, so this is one of the questions that you were mentioning earlier, that if you make a mistake somewhere, then obviously it's going to throw everything else out.
Yes.
With a question like this, we need to be careful. The first question is asking for total revenue, so that's easy. Total revenue is price times quantity. Okay, in the question, we need to look for price, we need to look for quantity. Okay, they gave you demand, they gave you costs, and they said P and Q is price and quantity. Okay, so TR is going to be P times open brackets, Q is 6,000 minus 3P, and then obviously if you multiply out, you're going to have TR equal to 6,000P, okay, minus 30P squared. That should be an option.
Yes, option 3.
Option 3, you got that as well. Perfect.
Yes.
Question 3 says, what is the company's profit function? Okay, so profit function is profit equals total revenue minus total costs. All right, we've got the total revenue, so I can literally copy paste this, copy paste, and then I've got total cost here. They said this was the cost function. So the cost function, I would assume, is the total, unless you've got to multiply this by quantity. It just says this is the cost function. They didn't say total cost. I'm going to put it in first. If I need to multiply it by the quantity, we can. But let's see what we get. They just said this is cost. So again, I would have wanted them to be more. Function. Yeah, I would have wanted them to be a bit more specific. Total cost function rather than maybe the unit cost, because you could have unit costs as part of the formula. But I assume it'll work if we just put it in as is. Let's see what we get. If you look
at the format of the function as well, it's got 5,000 plus 2q. So that already indicates.
Oh, yeah, fixed and variable.
Plus variable.
That's a good point. Yeah, I totally agree. If you're looking at the formula, you could make that deduction and you could say, well, that's fixed and then that's the variable. And then you could basically assume that that's the total cost. Oh, yeah, so 100%, that's good.
Okay.
All right, so we've got that, copy paste. Then we need to simplify. Okay, so we'll have negative 30p squared. Okay, and then you've got, let's see, you've got negative. It'll be 2q. But now you have the this is for profit. Profit is quantity, total revenue minus total cost. Do I have total revenue? Yes, I do. Total revenue had P. Here you've got P and Q now. That's odd.
You're going to have to substitute that demand function into Q.
Substitute the demand function into Q. Yes, okay, but first we need to multiply out. So 6,000p plus 6,000p, okay, minus 5,000, negative 2q. All right, so that's what you've got. That was the function, and then I've got a q, and the q is 6,000. Okay, fine. All right, this we'll take, copy it, and we'll paste that here as part of the q to eliminate one of the variables, because we can't have two variables in one equation, and then we can expand again. All right, so copy paste. Let's see, this will be 12 negative 12,000, so it'll be negative 17,000. Okay, then you've got minus 60p. So 5960p.
Oh, sorry, just minus 60p. You're correct,
Minus 60p. Let's double check that just to make sure I'm doing it correctly. 6,000p minus. Oh, a minus and a minus is a plus. It's plus. So it's actually 6,060.
Yeah, that's what I got as well. Yeah.
Okay, good. Yeah, just got to be careful with the sign. Just got to double check. 6,060p, negative and a negative and a negative makes a positive. Negative and a negative makes negative and minus, so that's negative 17. Okay, great. So then this is going to go. All right, so you've got minus 30p squared plus 6,060p minus, that's 12,000 minus 17. Okay, great. All right, can I divide that by 30? I think so. Let's double check. 660.
Just check. I think the answer is in that format.
Oh. Yeah. Okay. If we look at the options, is that the answer already? Oh, yes, it is. Great.
Yes.
So we don't have to simplify. All right. So option. Let's see. Minus 30p squared. Okay. Plus 6,060p minus 17. Option 3 again.
Yeah. Yes. That's what I also got.
Well done. Good. It's looking good. Okay. What is the price? At what price is revenue a maximum? Okay, so remember our total revenue function, this one? You need to find the derivative when you see min and max. Okay, derivative of total revenue is going to be 6,000 minus 60p. Okay, remember when it's a max or a min, you make this derivative equal to 0 and then you solve for p. So 6,000 equals 60p. So P equals 6,000, well, it'll be 100. Let's double check. 6,000 divided by 60 is 100. So price would be 100. Yes, the option 1. Did you get the same thing?
No, I actually couldn't get the answer. I just want to... Okay, so you actually took the total revenue and not the profit function.
Okay, here they said at what price is the revenue at a maximum. So
okay,
the revenue...
the answer. Yeah,
the revenue is being maximized. So when you're maximizing revenue, the total revenue function is obviously given as a quadratic. Okay, so 6,000p minus 30p squared, that's total revenue. To get the min or the max in terms of revenue, you would have to find the derivative of the total revenue function.
I took the derivative of the profit function.
Okay, if you're deriving the
question
profit function, then you're finding the min or maximum profit. You're not finding the min or maximum revenue. Yeah, just be careful.
Yeah, the thing is, because question 3 was profit, I didn't read it, I just assumed.
Oh, okay, you assumed you had to just find the derivative of this. Yeah, just be careful. Those questions are related, but they're different. Yeah, so this one asked for revenue.
While you're on this subject, actually on the study guide, they give another quadratic function that you can also use to get to the same answer, which is basically Q equals minus B over 2A.
Yes, minus B over 2A is the turning point. So if you go to the mathematics, if we had to do more mathematics, they talk about the quadratic as like that, and then the y equals ax squared plus bx plus c. So those 2 points you can find, which are your x-intercepts, and those x-intercepts are found when you have y equals 0. Then you find those intercepts. They call them roots. Okay, so those roots can be found using that. And then when you have any parabola, any graph that does that, okay, it doesn't matter where the graph is on the Cartesian plane. Okay, that turning point, okay, that middle point, okay, that point of, it's like a mirror. What's on that side is the same as that side. It's a mirror image. Okay, that turning point can be found using x equals minus b over 2a. Okay, it comes from the quadratic equation. Right, it's just a way to find the x value of the turning point. All right,
so
you can find
I can use any of these 2 functions and both would work.
Well, it depends on what you've been given. If you've been given a quadratic function that looks like that, and you've got the a, the b, and the c, then you can use this. If you don't, then you have to use the derivative. Right, derivative equals 0 gives you this point over here. Okay, because remember, here the m is decreasing, and then here the m is increasing. So the m here is minus, and then here the m here is plus. At some point in time, the m equals 0. Okay, it's that turning point where the gradients change. Right, that m equals 0 is looking at the derivative equals 0. The derivative is actually the equation to get the gradient, or for any point basically.
Okay.
All right, that's just just a bit of theory just to recap that. Is that all right?
Yeah, no, that's 100%.
Okay, good. All right, let's go back to the past paper. Where's my... Come on, why can't I alt tab? Okay, there. Okay, question 5. A company manufactures bicycle pumps. Each pump sells for 50 Rand, and the variable cost of producing each unit is 9% of the selling price. Okay, so I can see I've got fixed and variable. Okay, I've got selling price, and then I've got break-even point. Okay, so break-even point, BEP equals, this is fixed cost divided by open brackets SP minus VC. Okay, that's a formula from the textbook. Copy paste. All right, what was my fixed cost? They said here the monthly fixed cost incurred by the company is 50,000. Okay, they tell you that each pump sells for 50 Rand a unit, and they tell you the variable cost is 9% of the selling price. So open brackets, 50 Rand times 9%. Close brackets. All right, and then this needs to be typed into the calculator.
That formula that you used, can't you also use total revenue equals
I just want to highlight here, obviously you would round up because you can't sell a portion, a fraction of a unit. Good. If you go total revenue equal total cost and you work it out that way, that's good. Okay, you're applying the mathematics correctly. This is just another way of doing it. This might be shorter than that, but it depends.
I prefer using obviously the shorter one.
Yeah. Okay, so this is something that you can maybe write down on a piece of paper and keep it for when you're doing your assessment. You can just refer back to these formulas. Ooh, I deleted the wrong one. Here, delete that. Okay, either or will work. It doesn't matter as long as you're getting to the same answer. Happy?
Okay. Yeah.
Okay, 6. The employees at a certain company prefer buying hamburgers at their cafeteria. There is usually a demand for 100 burgers. When the price is that, it is known that for each R1 increase in price, demand increases by 1 hamburger. Okay, so obviously this is looking at inelastic type of thing, the demand, okay, the demand changing, but this, what do they want you? They want you to find, it's just the function. Okay, that's pretty straightforward.
Yeah, demand function.
Yeah,
Yes.
so obviously demand equals, if we look at this question, demand will be a straight line, so y equals mx plus c. Okay.
I actually use the formula Q equals A plus BP.
Okay, yeah, you can use the other equation, but that's just a different equation representing a straight line. So each variable will represent something else. I'm just keeping it simple and using mx plus c and then just relating it to the question.
It's actually, I think, the same. It's the same function as this one. It's just because the variables we're using is P and Q, and I think P is dependent on Q.
Price would be dependent on quantity. Yes, that could be yes, right. Yeah. Or it could be the other way as well, even. Okay, so here you have to look at what they're saying. Yeah. They said determine the demand function with quantity as a function of price. So P is the Q as a function of price. So Q is quantities demanded as a function of price. So in other words, the function is Q. The function is the quantity. Does that make sense?
Yes. Yeah.
Yeah. So that would be the Y. Yeah. So you're right. The Q would be the Y, and the X would be the
Q.
P.
Yes. Okay, yeah, sorry, P. You're right. Sorry. Yeah.
Yeah. If we relate it to what they've got here in terms of independent and dependent variables.
Yeah.
All right. So employees at a certain company prefer buying hamburgers at their cafeteria. Okay. So demand for 100 hamburgers. So in other words, quantity. Okay, and price. It is known that for each R1 increase in price, demand increases by 1 hamburger. Right. So change in Y over change in X.
Yeah.
Is obviously 1. Okay, 1 over 1. 1 over 1 is 1. Does that make sense?
Yeah.
Okay, so literally you're just plugging that into your equation. All right, let's actually change the variables because we spoke about it and then we have the right thing. X would be the P. All right, so what do I have? 100 equals 1 bracket 25 plus C. Okay, C is obviously 100 divided by 25. Okay, 4. Did they want that? No, they didn't want that. Well, that's the formula. Let's see. Determine the demand function. So if it's the demand function would be, copy paste that. I would have 1 here and I would have 4 there. Okay, because you don't have a 1 and a 4 there, it's probably a bigger answer. Let's see. Okay, so let's write it in the same notation as them. So let's write Q as 4 minus P. Alright, so can I make it look like one of these? No, I can't.
The answer I actually got was Q equals 125 minus 1P.
125 minus P. Let's see, let me read it again. There is usually a demand for 100 hamburgers when the price is 25. So when the price is 25, there is 100 hamburgers. It is known that for each 1 rand increase in price, demand increases by 1 hamburger. So plus 1 over plus 1 is 1. Okay, so that's definitely right. Let's see. When I did the substitution, okay, I had M. What is my P? My P was 25. This is, oh,
be minus.
Sorry. Yeah, this is silly mathematics. Sorry, this is a minus, not a divide. I don't know what's going on. Sorry, my head's not in the right space. I need to just wake up a little bit. Okay, sorry about that. That's minus.
No problem.
Plus. Okay, plus. It'll actually be minus. So it's minus 25. So it's actually option 1. Because you've got 100. 100 minus 25 is 75. 75 equals C. Okay, so this would be plus 75. So it'll be 75. Let's see. Okay, so 125. There's P. P times 1 is 25. Okay, 100 minus 25 is 75. Okay, so you have C equals 75. All right, Y equals mx plus C. Q equals 1P plus 75. So 75. The sign. Demand is a negative line because demand is sloping down. So this would be a minus 1 because the demand function
also had that as minus 1
is sloping downwards. Yeah, we need to look at the economics. All right, so we need to show 1 and then we'll get the plus 75 minus the P, and then that's fine. Okay, all right, so yeah, option 1 actually. Did you go with plus instead of minus here, I think?
No, I did go with minus.
You said 125.
Yeah, I got 125 minus P.
125 minus P.
But like I said,
first hold on. M is minus 1. If M is minus 1, then P would be plus 25.
Plus 25.
Yes. So yeah, the sign does make a difference. Okay, you're correct actually, because the M we said was demand. Demand is negative.
Yes.
So if you've got the minus P, then obviously the Q needs to update. Yeah, we didn't update the Q. I only updated the P. That's right. Minus.
Yes.
And we've got minus, that's fine. Okay, that's better. Okay, well done, you're doing very well.
Oh, thank you.
Okay, question 7. All right, so here we've got roots of the function. Okay, this is 0 equals x squared. Okay, plus x minus 6. Right, because you've got a trinomial, you can factorize. So I'm going to have x plus 3, and I'm going to have x minus 2. Okay, so I'll have x as minus 3 or x as 2. Okay, so minus 3 and 2, option 1. Same answer?
Yeah, I've also got option 1. Yes.
Good, it's looking good. Okay,
Yeah.
8. 8 says, okay, simultaneous equations. We need P, Q, and R. Okay, these ones you need to be very careful. So I'm going to write them both. I'm going to write all of them down actually. Let's write them all down and then we can look at the workings just now. Minus P plus Q plus 2R equals 8. Equation 1. Leave space. P plus Q plus 2R equals 0. Okay, final equation, 2q minus 2r equals 2. Okay, all right, so looking at this, you can see that this equation only has 2 variables instead of 3. Do you see that? So I can actually write down 2q equal to 2 minus 2r plus. Okay, let's double check. 2q equals 2, this goes across, it'll be plus 2r. Okay, there we go. So now that I know that 2q equals that, I can simplify. Q would equal 1 plus r. Alright, so now that I know what q is, that can be substituted into those two equations. Okay, so q is going to change for both of those. Alright, so where I have q, I want a bracket. Okay, then we need to simplify that. So minus p plus 1 plus r plus 2r equals 8. Okay, for this one, I have p plus 1 plus r plus 2r equals 0. Okay, can I simplify? Yes, so minus p plus 1 goes across. Okay, so I'll have plus 3 here. Okay, and then this will be equal to minus 7. Alright, in this one, I'm going to have p plus 3r equals minus 1. Okay, so can I make p the subject? Yes, I can. Let's make p the subject here. P equals minus 1 minus 3r. This needs to be substituted into there. Okay, so minus open brackets plus 3r equals 7. Okay, can I solve for r? Yes, I need to multiply out. So minus and a minus is a plus. So 1. Minus and a minus is a plus. 3r. Plus 3r equals 7. Okay, 3 and 3 is 6. 1 minus 7, or 7 minus 1 rather, is 6. So r equals 1. Okay, so now that you have r equals 1, plug that into here. Okay, p is ooh, I hope I still have the connection. Is the connection still there, Rain? Are you still there? Hello, Raina, are you still there? Okay, I get P equals minus 4. That's
No problem.
okay. All right. So I'm not going to touch F2 because that's why the signal is dropping. It's going on airplane mode basically. I've got the R, I've got the P, and now I just need the Q. Okay, so if I copy paste this here and I plug in P as minus 4 or R as 1, here I only need the R. So obviously 1 plus 1 is 2, and that's going to give me the Q. In the question, they wanted you to work out the sum. Okay, so P plus Q plus R equals, what is P? Minus 4. What is R? 1. And what is Q? 2.
2.
Okay, so minus 4 plus 3 is minus 1. Did you get that as well?
Option 2.
Very good. Okay, and these are normally quite challenging, so if you're getting them right, that's a good sign. Nice one. Question 9. So far you've got full marks. That's very good.
Yep.
Okay, you need 6 more to make sure you pass. Okay, this question I'm just going to do on screen. It's easier for me just to write here. Okay, so I'm just going to multiply this out. Okay, multiply that out. All right, so this is going to be the same as, okay, 3 to the 2, a to the minus 8. Okay, when you have exponents being raised by an exponent, you just multiply it out. Okay, so plus 6. Right, that's the numerator. Denominator, take the 2, multiply it in. The 3 is, yeah, the 3 will be plus 2 is right. Okay, so I just want to double check that. And that's fine. Yeah, that's fine. Okay, this one. The 6 will have 6 squared. Okay, here I've got a to the 4. I've got b to the minus 2. And I've got c to the minus 4. Okay, then I need to simplify. So 3 times 3 is 9. 6 squared is 36. Okay, I can cancel here. Actually, I don't cancel because the a is going to go to the bottom. So if it's minus 8 at the top, when it goes to the bottom, okay, or you could bring this to the top, either or, doesn't matter. All right, so you could bring this to the top, then it'll be minus 12, or if you bring this to the bottom, it'll be plus 4. So I'll have a to the 12 here in the denominator, and then I'll have b here. So b minus 2 goes to the top, I'll have b to the 8 plus 2. And then I'll have c, it's minus 4, I'll take it to the top, so c4. Okay, so this is going to be...
that a that you took to the top,
I took it to the bottom, not to the top. I took the minus 8 to the bottom.
Okay, sorry. Yeah.
Yeah. So when I take it to the bottom, it becomes plus. If I take it to the top, it becomes minus.
Yep.
Okay. So I've got that. That cancels. I'll have 9 goes into 36 4 times. So B8 C4 over A12. Is that an option? Let's see. I've got B8 C4 over 4 8 to the 12. Yes, option 3. Did you get that?
No, I struggled with this one.
Okay, yeah, it's just the rules with the exponents. So let me just help you with the rules. When you have x1 and you're timesing that by, or let's make it a 7 just to make it more clear. If I have x to the 7 and I'm raising a power by a power, then you multiply. So then you say x7 times 2, which is x14. Does that make sense?
Yep.
Okay, when you have this, x to the a, well, don't put a's, let me just keep it numbers. Right, let's say I have x to the 2, and I'm multiplying by x to the 3. Okay, then you add to the exponents. Then you'll have x to the 5. Does that make sense?
Yep.
All right, if you have this, x to the 9 over x to the 7. Right, then you write that down as x to the 9 minus 7, which is x squared. Or you can just cancel and cancel. Does that make sense?
Yes, yeah.
Okay.
I think my big problem is with the negative exponents.
Yes. Okay. When you have a negative exponent, this just means it's in the denominator.
1 over x.
1 over x, exactly. All right. So if it was x to the 2, it'll be minus 2. It'll be x to the x squared. 1 over x squared. Does that make sense?
Yep.
Right, if you have this 1 over x to the minus 3, then you've actually got x to the 3, because this is going to go to the top. All right, so when you have a minus, you just bring it to the top or you take it to the bottom, adding or subtracting. Is that a bit better?
Okay. Yeah, yes.
Okay, let me just quickly screenshot the answer, so at least there are workings here. Okay, what did we went with? Option 3. Okay, so this one you didn't get. Did you choose a different option?
Yeah, I couldn't get the answer.
Okay, got stuck. Okay, so just be careful with questions like this. You need to apply those exponent rules. Okay, here, the first thing I had to do was get rid of the brackets. Okay, BODMAS, get rid of the bracket first, then eliminate and cross-cancel the variables, numerator, denominator. Is that right?
Yeah.
Okay,
Yes.
Feeling better about it?
Yeah.
Okay. Here we need those log rules. All right, I'm going to have to use the exponent. I don't have my textbook with me, unfortunately, but I'm going to use those rules, and we'll reference the textbook. I actually need to open it up. I don't think I opened the study guide. Okay, so the study guide, it's the one that had the additions. I think this is the right one. Okay.
Yeah, yes, that looks like the correct one.
All right, so we'll search for the log rules.
Was also two that I struggled a lot with. Yeah, not 100% with log and lin and.
Okay, lin is just log with base e.
Yes. Yeah.
Okay, so if you do want me to cover specific rules, we can look at it. The best approach is to just highlight those formulas, those log rules. Where's those log rules where you're adding and subtracting logs? Let's see. I think I might have gone past it. Okay, here. Non-linear functions. There. That's logarithmic growth.
They've got an additional chapter basically with mathematic basics, and I know they cover log in there.
Solutions. There. Yes, this is the right bit.
Mathematical background, yes.
Yeah, this is the right bit, and I'm looking for the log rules. So further down,
at the power, or
sorry, I've got linear.
Yeah, maybe go down.
I've got non-linear. There, logarithms.
Yes.
Okay, 4.3, page 183.
Yep.
Okay, this is 175. Okay, there we go, log functions. All right, so yeah, that's the log. Okay, the textbook, or the study guide, I should say, gives you all the information in terms of what the textbook has identified. Right, that's how you represent a log. Okay, when you have a log with the b as an e, okay, in other words, log base e. Log base e means ln, so you just write ln x instead of log ex. Does that make sense?
Yep.
Okay, that's just the normal log. In terms of conversions, okay, here's the rules that we need. Okay, the plusing and the minusing and all of that. All right, so what does the question say? Okay, you've got a minus here. So when you have a minus, you're applying this rule. Do you see it? Okay, same base, two separate amounts. Okay, when you're subtracting, you're going to have one log, okay, with m over n. Right, so, okay, let's have a look here. Okay, so we've got the 3 and the 2 though. I'm just going to have to double check just to make sure. When you have that 3, I think you just leave it as is. Let's quickly double check that here. Okay, no, it's not. You don't just leave it as is. You've actually got to build it into the question. All right, so when there's a number outside, okay, if there's a 4 outside this log, when you apply that rule, remember, it's the m over the n. Okay, I've used that here, or they've used it here, and we need to use it as well. Okay, so you can see the 4 is actually going to go as the exponent in the m, and then the 3 is going to go as the exponent in the n. Okay, m over n.
Okay.
All right, so that's something we need to use. All right, that's important to know. That's something to maybe jot down, especially for logs, all right, when you have a question like this. All right, so I just need to use the right rule. Okay, now that I have the right rule, I can work it out. All right, so I'm going to have, this was equal to 7. Okay, so if I rewrite this according to the log rule, I'm going to have ln 5x to the 3 over x squared, close brackets, equals 7. So this will cancel with that, so I'm going to have ln 5x equal to 7. Okay, when I have ln 5x equal to 7, I can write it down like this. Let me just erase some of this so there's more space, because I want to copy this just now. Okay, so then I have this. I have log base e to the 5x equals 7. Okay, when I have something like that, I just remember that easy log function. 2 to the 3 equals 8. Okay, log base 2 of 8 equals 3. All right, so how do I represent this as that? I need to relate it to this. All right, so E is my base, E is the base, E is the base, E is the base. So E, okay, 8 is the answer, 8 is the answer. So 5x. Okay, then I've got 5x is the 8, 5x is the 8, 5x is the 8. Okay, then I've got the 7. The 7 here is the exponent. Okay, the 7 there is the exponent, which is the 7 there. All right, so then I've got x equal to e to the 7 over 5. All right. I don't have my scientific calculator with me. I'm gonna just copy paste this and then I'll use Excel. Let me quickly just get this. Okay, I want all of that. Actually, just that. That's the answer. Okay. Did you get an answer for this one? Or this one you struggled with?
Yeah, yes.
Okay, struggle with this one. All right, so the answer is e to the 7 over 5. Okay, does Excel have an e function? If I write e, I don't think so.
You want, I can do it on my calculator.
Yeah, you do it on yours. I'm gonna bring up the scientific calculator. Okay, try it on your side and see what you get.
So e to the 5 over 7.
Yeah, so e to the power, okay, there's e. E, I'm going to have to make a function. Ooh, clear?
So
okay.
I got 21.20187987 for that.
Ooh, how do I work this out here? Okay, I see it. Okay, I see what I'm doing. All right, sorry, I don't normally use this calculator, but anyway, I have to today. So, okay, that to the power 7. All right. Oh, okay, e to the power 7 is 7. No, that can't be right. E to the power 7, what am I not doing? Oh, pressing equals. Ah, there we go. That's the answer. And then divide by 5. Answer. Okay, did you get 219?
Yeah. The first time not, but when I did it like you did it now, yes, yeah.
Okay, that's good.
0.3266317.
Okay, yeah, perfect. Okay, so that's the answer. All right, x equals, paste that figure. All right, so answer option 3. Okay. All right, 11 says evaluate this. Okay, so delete all the stuff. Okay. All right, this one I'm going to write as well here. Okay, so log 18 over this. Okay, this calculator. Okay, don't try to do it mathematically. It's not necessary. All right, you can just type that into your calculator. Save time in the exam. Okay, you type it into your calculator. I'll use Excel.
34.8.
Yeah, if they do give you these questions, you should be grateful because they're very easy.
Okay.
They're nice questions. You agree?
Yeah, no, definitely.
Okay, what's the number? I'm going to have to work that out. 34.8 divided by 1091.7, close brackets. Okay, then the base is 18. Okay, what did you get as an answer?
Minus 1.192190588.
Perfect. Option?
Yeah.
2.
2, yeah.
Great. Right, number 12. Okay, demand function, PDPS, P and Q, price and quantity to determine equilibrium. Great. So, Q squared plus 2Q plus 5 equals 29 minus 3Q. Okay, next step, take everything to one side. Alright, so I'm going to have a minus 29 and I'm going to have a plus 3 equals 0. Okay, double check. Take that across, minus 29, take that across, plus 3, it's correct. Okay, then I'm going to have Q squared plus 5Q. Okay, this will be plus 5, so minus 24. Okay, let's double check that line because I'm just copy pasting. Q squared, okay, 2Q plus 3Q is 5Q. Minus 29 plus 5 is minus 24. Do you agree with that?
Yep.
Yeah, that looks right. Okay, can I simplify that? Let's see. 8 times 3 is 24. Yeah, that does work. Okay, so I can work this out using trinomial factorization. Okay, Q minus 3. All right, equals 0. All right, let's double check that. Q squared, yes. Minus 3. Okay, minus 3 plus 8 is plus 5. That's correct. 8 times 3 is 24. Minus and a plus is a minus. That's correct. Okay, so Q can be minus 8 or Q can be 3. Obviously, you don't get negative quantity, so Q must be 3. All right, so Q must be 3. Once you've got Q equals 3, then plug it into one of the equations. I'm going to use this one because it's easier to plug in. I'm going to use PS equals. Okay, so price supplied equals, okay, 3 times 3 is 9, so PS is 20. Okay, so P is 20, Q is 3, option 1. Did you get option 1?
Yes, yep.
Well done. 13. Okay, 13, P and Q, that's the function. Calculate consumer surplus for the demand. Okay, so I like drawing this, okay, because you're looking at consumer surplus and you're looking at demand. Okay, so you first need the equilibrium. Okay, so I need a point actually. I don't need the equilibrium actually because I'm looking for a point at P. Alright, so I've got Q and I need to work out the P. They say price is 10. I want to know what the Q is. Okay, and then obviously P here, if Q is 0, P is 58. Right, there's my diagram. Alright, so this point I need to calculate. I'm going to plug in 10 here. Okay, so I think let me work this one out separately. Okay, so 10 equals 58 minus 0.4 Q. Okay, solve for Q. So I'm going to have 0.4 Q equals 58. Okay, minus 10. Okay, so 0.4 Q equals 48. All right, double check that. Yeah, that looks right. Okay, then that's going to equal 48 divided by 0.4 is 120. All right, so 120 is Q. All right, area under the graph. Okay, so area equals half base times height. Okay, half the base. What is the base? The base is 120. Okay, times the height. The height is 58 minus 10 is 48. All right, so that's the answer. Okay, I'm just going to copy that. All right, so there's the working for it, and then I'll write the answer in Excel. Okay, so consumer surplus is going to be A equals, all right, half base times height, 2880, option 3.
Yep.
Same answer?
Yep. Yep.
Very good, nice. Next, question 14. Question 14 says calculate the consumer surplus for the demand function. Okay, when you have this, then we need to work out that that integration thing because this looks like a quadratic function because I can see this is in the denominator. Okay, there's a problem here. So when I have something like this, I need to go back to the textbook or the study guide. Okay, you don't have the textbook, and I need to look at the consumer surplus when I have a quadratic function. All right, so go to your index. We actually looked at this previously. I think it's over here. Yeah, consumer surplus, page 109. Okay, page 109. This is 110.11. Here's it. There we go. Okay, there. Consumer surplus is found algebraically using that. Okay, area under the curve from that point to that point. Okay, obviously we'll work out what that point is, or it might be given, right? But that's what you're looking at. Right, I want that formula. Do they give you a general formula for it? Do they? They should somewhere. Yes, they do. Okay, there. I'm gonna snapshot that. Okay, this is what I want. Okay, I'm going to do this on the actual page, just after I delete all of this other stuff. Delete. Okay, so let's do the working. I'm going to have the integration. Okay, let's go back and have a look at that formula. Okay, I've got 0 to Q0, all right, bracket demand function. Okay, and then obviously minus the P0 times the Q0. All right, so if I look at this question, okay, maybe let me show you this one. All right, so here you're looking at 0 to 8. Okay, remember 8 here is the Q value. All right, so I need to work out that Q value when I have a P value. That's something that you do have to calculate. That I can do here. P equals 25 divided by open brackets Q plus 2 close brackets. Okay, take well, not take anything to one side. First plug in the value. What is the value of P? P was 5. Okay, so then I'm going to have take the bracket to that side. So I'm going to have 5 times the bracket. So I'll have 5Q, okay, plus 10 equals 25. Okay, 5Q equals minus 10. So I'm going to have 15. Okay, Q equals 3. Okay, so I have Q equals 3. So now I know in terms of my function, okay, I'm going to have 0 to 3. Okay, then I'm going to have 25 over Q plus 2, okay, minus P0 Q0. Okay, so let's integrate this thing. Again, all right, if you go back and you have a look at it, here, this one. All right, when you have this in the denominator, okay, remember, this is those what's it called? Those derivative formulas. Okay, where you're going function to derivative or derivative to function. Okay, here I've got the derivative. I'm going back to the function, right? Because this is integration. So integration is going backwards. It's going from derivative to function, right? When you go back, you use the ln. Okay, when you have this in the denominator. So I'm just going to use this. You can see it's just going to be 100, whatever the number is, okay, and then ln whatever the bracket is. All right, is that all right?
Yep.
Okay, so I'm going to apply that here. Okay, so I'm going to have ln. What is it? It was 25. Okay, so 25 ln.
25 ln. Yep.
Yes. Okay, and then the bracket, which is what we had there. Okay, just double check, make sure we're using the rule correctly.
Yeah.
Okay, plus 2, and then this must be 0 to 3. Okay, minus P0 Q0. Okay, that we need from our diagram. Well, from our calculation. Okay, so P0 and Q0. Q0 we said was 3. Okay, so we've got the 3. What is the P0? I think P0 would be the 10. Yes, okay, because P0 is that point there, and that point represents the Y for that value. So Q0 and P0 is the point on the graph. Okay, so that would be the 10. Okay, so P is not P, was it 10 or was it 5? It was 5, sorry, I don't know why I'm saying 10, it's 5. Okay, I'm thinking about a maybe different question. Yeah, the other P, yeah, question 13 P was 10, question 14 P is 5. Okay, so P is 5. All right, so we're going to have 5 times 3. Okay, so next step would be to put in the Q. So I'm going to have 25 ln, open brackets, 3 plus 2 is 5. Okay, minus 25 ln, 0 plus 2 is 2. Okay, close bracket, minus 15. All right, and then that I'm going to type into my Excel. So I'm just going to copy that working. All right, so copy paste that. All right, so you have a working for this one. Okay, we've got the formula, we've applied the formula, and we're going to get an answer here. So equals 25 ln, open brackets 5, okay, minus 25 ln, open brackets 2, close brackets. Okay, this whole thing needs to be at brackets, and then we need to subtract 15. Okay, answer 15. Is that an option? No. I think Excel doesn't like this. Excel doesn't like it somehow here. Ooh, I see something wrong here. I see it's 25 times 15. That's wrong. Okay, let's redo this. Okay, let's do it separately. I think the Excel formula is not right. Ln 5. What is ln 5? Okay, that's ln 5.
Yeah,
ln 2
yes.
is 0. Ln 2 is 0. Okay, interesting. All right, so if that's a 0, then you'll have a 0 there. So it'll just be 25 times this, 25 times that.
I get a different amount on a calculator for ln 2.
Do you get a different one?
0.693.
Ln, I'm typing ln 2. Oh, maybe let me put it in the brackets. Does that make a difference? Oh, okay, yes.
Yep.
Okay. Yeah, just be careful here with the Excel. All right, so yeah, you're right. Okay, on the calculator, that's the right figure. So then it's going to be this minus. It'll be minus 25. So 25 times that. Okay. Right, minus 25. So that's a minus. Okay, and then I obviously have to minus 15. All right, so answer here. Answer here is 7.9. Yeah, 7.9 is there. Option 3. Did you get that? Did you get option 3?
Oh,
Ooh.
sorry. No, I struggled with this one.
Oh, okay.
Yep.
Is it all right now? Can you see what to do? All right, you're just following that consumer surplus formula that the textbook had provided for this question. You have to find the integration first.
Yeah, I think I wasn't sure which formulas to use. And,
okay.
But yeah.
Is it all right? Does that help, eh?
Yeah, definitely.
Okay, yeah. So when you see a question that looks similar to this in future, just reference this and then you can use the same formula. There's the formula. That formula you need.
Okay.
That's the one. Okay. All right. It'll get better over time. If this was a written paper, maybe if you didn't remember that, you could have skipped it and you could have come back to it later. Remember, get 15 right and then go and look for your distinction.
Okay.
Okay, let's have a look at this one. You've got P and Q, that's fine. Producer surplus. Okay, diagram again. Let's draw it. Nice and simple. Draw up the diagram. It'll look something like this. Okay, what am I looking for? P90. Okay, so P90, let's just draw it somewhere there. Okay, and I'm looking for Q. Okay, so this point is 50. No, this point is 50. Okay, P, and I need to work out a Q, and I need to work out this value there. Okay, so delete that. We'll write in a value. All right, so let's plug in. This I can do on Excel. Okay, P equals 50 plus 2Q. Okay, I've got 90. equals 50 plus 2q. Take that to that side, so I'll have minus 50, so I'll have 40 equals 2q. So q is 20. Do you agree?
Yes, yeah.
Okay, so let's see. This is producer surplus. Okay, so we've got 20 here. And then I need to plug in a 20 to get a P. Okay, so what is 20 times 2 is 40, plus 50 is 90. There's the 90. All right, area under the graph, so half base times height. Okay, so do I have everything? Yeah, I do. Okay, so area equals half base. What is the base here? Base is 20. What is the height? 90 minus 50 is 40. Okay, 40 times 4, that's 800. 800 divided by 2 is 400. Okay, option 2. Did you get that one?
Yeah.
Well done, good. Okay, let's copy paste. There's your working for that one. I must say
these ones are a lot simpler if you just draw out the diagram and...
Yes, look how easy that was.
Yep. Yep.
Right, I like drawing these pictures because then you can see it. You've got the P, you've got the Q, and you know you need the half base times height because it's a triangle. Yep. Okay, what number was this? 15, yeah, perfect. Paste, option 2. Right, 16. Okay, so theoretically you would have passed the question or the paper already, and now you're looking at other questions to get the distinction. Okay, so 16 and 17 looking at one formula. Okay, that's the big formula here. Let's copy it. Okay, you're probably going to have to use it. This looks like a substitution question to me. Okay, T is the number of days, and they're looking at approximately. So this is the number of units. Okay, so substitute the days in to get the number of products sold. Right, the rate of sales 20 days after. Okay, so literally just plug in the T. All right, so insert T equals 20. Okay, this I'm gonna have to do using some steps. Okay, so I'm gonna work out minus 0.3. Okay, this I would just ask you to just type into your calculator and then you give us an answer. We'll just check if it's right. Okay, 1.5. Okay, gives us 4.5. All right, so I need E to 4.5. Okay, where's my calculator again? Okay.
Check here quickly. E to minus 4.5.
Is that right? Yeah. Bracket minus. Minus. I don't know if this will work. I hope it works. No, this will work. There, that one. Ooh, negate, no. Backspace. Can't backspace. Let's try again. Okay, E to the power. Well, I'll just make it 1 over. I'll divide it by 1. Yeah, let's do that maybe. Okay, so let me just write E. Okay, to the power. What am I looking for? 4.5 equals. Okay, then this figure will be the inverse, so it'll be 1 over. So 1 over 1 divided by that answer is, okay, so that's that figure. Okay, so I've got that. All right, so ST or S20 equals 1,800 plus 1,500, multiply that by 0.011109 dot. Okay, which gives me an answer of, okay, 1,800 plus 1,500 times this figure. Okay, I get that.
Yeah, yes, that's what I also got, yeah.
Perfect. Okay, option 4.
Yep.
Number 7. Okay, how are we doing with time? Are you still alright?
I have to go in, let's say, I've got about 8 minutes.
Okay, all right. Let's spend another 8 minutes. Let me try to get through a few more. Then I'll have a few left to do, and then I'll do the rest, and then I'll send it to you, and then you've got the answers here. Let's just see how many we can push through and carry complete. Okay, after how many days rounded to the whole number will it take a rate of? Will the rate of sales B 2,000 units. Okay, so now you've got the opposite. Okay, you've got 2,000 units equal to 1,800 plus 1,5. Okay, e to the power, open brackets, minus 0.03, no, not 0.3, 0.3 t plus 1.5, close brackets. Okay, all right, obviously move that across. I'm going to have minus, I'll have 200, 200 equals, okay, I'm also running out of battery. Can I quickly plug it in? Let me just get my charger.
Okay.
Okay. All right. It's charging. Let's complete this one. Equals 200 equals 1,500. Okay. Actually, let me just copy it. It's easier. Okay. Then I need to divide. So 200 divided by 1,500 gives me that. And then I'm obviously going to have E. Okay, then I need to remember what we had earlier. Okay, remember this? 2 to the 3 equals 8. Log base 2 of 8 equals 3. Okay, you can have the same thing here when you have E. So let's go back. Here I've got what? I've got a number, okay, equal to e to the power. Okay, so I've got this here. I've got 2, I've got a base with a power, okay, equals an answer. All right, so I need to change it to a log. All right, so if I apply the log, right, what is the base? The base is e. All right, so log base e, okay, of the answer. What is the answer here? The answer is 8. The answer here is 0.1333, close brackets, okay, equals. Right, what is the exponent? The exponent is negative 0.3 t. Okay, so on your calculator, obviously log base e would be ln. So it'll be ln open brackets, that answer, close bracket, gives me that. Okay, that's going to equal minus 0.3 t. Okay, so to get t is going to equal, t will equal this divided by, okay, negative 0.3. Answer 6.7. Obviously, this is number of days. Did they say round it off? Yeah, they did. They said round it to the whole number. Right. So you would choose option 2. Is that all right?
Yeah. Yes.
Okay, this is a short one. That one we can probably do, and then we can wrap up. I think you need to go soon, so let's see what this one's looking at. Question 18, and then I'll finish the rest. Question 18, the demand, P equals 215 minus 5Q, where P and Q are the price and quantity respectively. Determine the point elasticity of demand if P is that. Okay, so this is linear. You need the formula. Okay, do you know what page this is on? Have you bookmarked it?
No.
Elasticity of demand. Okay, I see it. Page 14.
Okay.
It's right at the beginning. Let's see. Point price elasticity of demand. Here we go. This is supply. Here's demand. Price elasticity of demand. Okay, I'm looking for the point here. And is this linear? Was it linear?
Yes.
Yes, it was. Okay, so if it's linear, I need to use this one. Here's it. Okay, you could use any one. I can even use, no, I can't use that one. I can use that one if I wanted to, but there should be a nice one with the variables. Looks like that is the nice one. Yeah, this one is the nicest one. Okay, so I'm just going to copy this. That is what I'm going to be using here. Okay, paste. All right, point elasticity of demand. Okay, I hope you understand what that is. I'm just abbreviating just to save some time. Okay, PED.
Okay.
The point elasticity of demand is denoted by that equation. Okay, in your question, okay, what is my minus B? Minus B is minus bracket minus 5. Okay, multiply that by open bracket. Okay, what is my P here? P is 15. Okay, over open bracket. What is my A? My A is 215. Okay, minus, what is my B? Minus 5. Open bracket, minus 5. Okay, multiply that by, what is P? 15. Close bracket, close bracket, close bracket, equals answer. Okay, let the calculator work that out for us. Okay, you get an answer of negative, not negative, positive. That's not an option. Okay, so this one looks like we are going to go. Let me just double check it though. Minus 5. Did I have minus 5? Yeah, minus 5 times. I did have times. Okay, this was 15. Let me just add more brackets just in case. Okay, this was 15 and then divided by, and then we had an open bracket there. We had 215, which was A. Yes. Okay, minus open brackets. This was B. Minus B, yeah, so I've got minus B. Let me add that as brackets just in case, times 15, close brackets, enter. Yeah, it's still the same answer. Okay, so for this one, is the demand elastic or inelastic? For this one, based on what you've got, the point price is, I just want to make sure, is this the same formula as the one that we used last time? Let me open up last time's, I just want to double check because I think we had a different formula, but that formula I took from the textbook. I didn't take it from the study guide. Okay, let me just go back here quick and just scroll and just see where's point elasticity of demand. Here, no, that's consumer surplus, producer surplus. That's equilibrium. Here we go. There. Yeah, see, I used this one. Do you see that one?
Yes,
Point
yeah,
elasticity of demand.
Yeah, yes.
Okay, so I'm going to copy that one because if I use the study guide, if I use that other one, I'm not getting an option that's there. So let's try this one, which is my open, yeah, this other one here. Okay, so paste. All right, let's try it with that. Okay, so ED, elasticity of demand, is P. P is the 15 over the P minus A. Let's try that. 15 divided by open brackets, the 15 minus the A, which was 215. Close brackets equals, I think this might even work. Let's check. Copy, paste equals, is that there? Yes, that's there. Okay, it's option 4. Alright, so you've actually got to use the textbook formula for it.
It's a much simpler formula.
Yeah, it is much simpler. Yeah, normally normally they ask theory questions about that where they have the P over P minus A and you just plug in the A and you choose the option. Okay, I'm going to pause there. I know you have to go pick up your daughter, so I'm not going to do any more with you live. I'm just going to record and do the rest. So I'll do 19, I'll do the next 10, 11 questions. But looking at what you've done, did that go quite well? Did you get 15 out of 18? Some I know you didn't do, but
yes.
Was it okay?
Yeah, yes.
Nice. Okay, because Reynolds, going forward, remember this is a practical subject, so you're just going to be practicing for the exam. You're not really going to be studying for the exam. Yes, you just need to go over some equations, but once you've got the equations, it's practice, 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 and then that's the best way to prepare. Okay, is that all right?
Yep. Yeah, no, yeah, it's getting a lot more simpler, and yeah, the more I repeat them, yeah, the more I remember, yeah.
Nice, yeah, it'll get better as we continue to more. All right, so I will send you older past papers, so you have a question bank, but I'll do that later on. Right now, you're obviously going through the newer past papers, so at least you can practice and you can get some of the workings done. Okay.
Okay.
Perfect. All right, Rena, I'm going to say goodbye. Go pick up your daughter, and then we'll chat again next week. Next week, I shouldn't have any problems. Sorry about this week again. I apologize, but let's try start on time next week. I know 2 o'clock is our starting time, so I apologize for that for today. Okay.
No problem. No problem. I mean, yeah,
Okay.
I wasn't anyway busy with other stuff, so.
Okay.
Yeah.
Thank you. Thanks for understanding.
Okay.
All right, Rena. See you next week.
Okay. Thanks. Okay. Bye.
Okay. Bye. Okay, question 19 says, consider the function. The second derivative and turning points are. Okay, so they want you to work out the second derivative. You've only got the function. Right, so I'm going to do this one here actually. Okay, so first derivative, f dash x equals. First derivative would be 3x squared minus 12x. Okay, that's the first derivative. Second derivative, so f double dash x. Okay, that's to denote the second derivative. This would be 6x minus 12. Right, then they said, what is the turning point? Okay, so the turning point is the point, the min or the max. Okay, and that you find when you have the derivative equal 0. Okay, so derivative equals 0, that I can do separately. Well, actually, let me do it here. Why not? I have enough space. Okay, so 0 equals 3x squared minus 12x. Okay, 0 equals, factorize, 3x, open bracket, x, this will be, I took out an x, so it'll be minus 4. Let's double check that. 3x times that is 3x squared, yes. 3x times that is minus 4, well, minus 12, yeah, minus 12x, perfect. Okay, so what can x be? X can be 0 or x can be 4. All right, so the second derivative, 6x minus 12, 6x minus 12, and x can be 0 and x can be 4. So option 3 looks good. 6x minus 12, x equals 0, x equals 4. Perfect. Okay, let me just copy that to our notes. Question 20 says, approximately how many units must be manufactured to maximize a profit defined by that function? All right, so obviously the function would be y. Okay, well, whatever it is, I'm just going to call it profits. Okay, profit equals approximately how many units must be manufactured to maximize a profit defined by the function. Yeah, so this is the profit minus x squared. Okay, plus 8x minus 16. All right, so if I'm looking for the maximize, I need to define the derivative to work out the x. Derivative equals 0. Okay, so minus 2x plus 8 equals 0. Okay, so 8 equals 2x, x equals 4. Alright, so x equals 4, option 4. Right, that's an easy one. That one you should definitely do. If you're going through the multiple choice, obviously you'd want easier questions. There are some other difficult ones. Obviously get the easy ones done first and then look at the more difficult. Alright, 21. Find the values of x for which the function that has a max or a min. Okay, so when you have that function, same thing applies, you need to find the derivative. Okay, so obviously dy over dx. Okay, working out the derivative because the function is y and I've got x. Okay, so dy over dx equals, I'm going to have minus 3x squared, okay, plus 18x minus 24. Okay, that needs to equal 0. So, copy paste, derivative equals 0. Okay, then I need to factorize. So, 0 equals, I can take out a minus 3. Yes, I can. Okay, then I have an open bracket, then I'll have x squared. Okay, minus 3 times x squared is minus 3x squared. Okay, then I've got a minus. I'm taking out a minus 3, so I need to have a minus 6. Okay, minus 6 times 3 is 18. Okay, so minus 6x. Then I've got a minus here, so I'll have a plus. Okay, because I've got a minus. So plus 8. Close brackets. Okay, let's double check. 3x squared, yes. That'll be plus 18x. That'll be minus 24. Okay, that looks right. Okay, next step, factorize. So open bracket. I've got an 8 plus and I've got a 6, so I'll have a 4 and a 2. So x minus 4, okay, x plus 2. Not plus, minus 2 as well. Okay, negative and negative is a positive. Alright, let's see. X squared, yeah, minus 6, yes. Plus 8, yes. Okay, so x can equal 4 or x can equal 2. Alright, so find the values of x where there's a min or a max. X is 4, x is 2, option 2. Question 22. Question 22 says the annual revenue generated by a television company can be approximated by the function. Okay, so that's the function for the annual revenue, where t is the number of years since the company started. Okay, the rate of change in revenue 15 years after the company started is. Okay, this is the annual revenue. Okay, so if it's the annual revenue, to get the rate, I need to divide. Okay, so they gave you annual revenue. Annual revenue equals the function. Okay, let's just copy the function. Right, that is the function. Okay, annual revenue in millions of rands generated by a television company can be approximated by the function. Fine, that's the annual. Then they say t is the number of years. Okay, the rate of change. Rate of change means divide by the number of years. Okay, so the rate of change in revenue 15 years after. Okay, so if this is the annual revenue, to work out the rate of change, I'm going to take the annual and I'm going to have to divide it by the time. That's the rate of change. Okay, so I'm going to have to take this whole thing and divide it by t. Right, and I have to plug in 15 because 15 is t. All right, so how can I write it? Let me write it here actually. Okay, so this whole function divided by t. Okay, and insert 15. All right, so okay, let's work it out. I'm going to have 5.78 plus. Okay, all of this needs to be in brackets because I'm going to divide it by time. Okay, plus. Then I've got 8.59 and then ln t. So I'm going to have to multiply this by open brackets, then ln open brackets that. T here is 15. Close that bracket, close that bracket, close that bracket. Okay, divided by number of time, 15. Answer, okay, 1.9. Is that given? That's not given, but that would be the rate in terms of, it's in million, hey? Yeah, in millions of rands. So multiply by a million. What do we get? Let's check. That times a million gives me 193. As a rand figure, 1.93 million per year, per annum. No, these are all very small figures. Okay, this is 87. That's way too big. 87 million. Let's go back and read the question again. They tell you that annual revenue in millions generated by a television company can be approximated by. That's the annual. So annual to me means the revenue that's generated over the year, where T is the number of years since the company started, the rate of change in revenue. 15 years after the company started is. Because I have Lin here, because there's a rate of change, I think you might even have to use a derivative here. Let's go and check, because this would be more of an average rather than a rate of change. So I think this is incorrect, because this would be all right. Obviously, if it's a rate of change in revenue, then I need to get a change in X, well, a derivative basically. All right, so I do think that you're actually working out the derivative first and then plugging in the 15. All right, let's work that out. Copy paste the function. Okay, derivative of this. Okay, the derivative of this is going to be what? Well, this would fall away, then we need to derive that. Okay, so when I have ln, okay, we need the derivative rules again, just to make sure that I'm using the right thing. Okay, derivative rules. Derivatives, here, differentiation. Okay, and I'm looking for logs and lns. Hopefully it's here somewhere, here, 63. Page 63, here's page 63. Where's those log and lns? Not here. Okay, it must be more advanced then. Okay, here we go. This is looking at that integration, integration. I need the more advanced derivatives. Where would it be in the study guide? Let's see. It's probably under maybe one of these. No, these are all exercises. Higher derivatives, no. Optimization, no. Here, it was page 63, but there wasn't anything there. Let's go back. Maybe I missed it. Page 66, go back to page 63. Ah, it is here. There we go. Chain rule, no. There we go. Okay, here. There's it there. Sorry, I didn't see it. Okay, so if you're looking for the derivative of the log function, so y equals ln x, okay, would equal 1 over x, right? So you're literally writing it over the variable, right? So this would be 1 over t. Okay, so now we've got it. All right, so derivative of this would be, it would be 8.59 divided by, so it'll be 1 over x, 1 over t. Will be the derivative. The function was that's obviously the derivative. So if I'm inserting years, I need to insert the 15. Okay, so copy paste, insert 15. All right, multiply by 1,000,000. That's an option. All right, so this would be the rates. Rate of change in revenue. Okay, so option 3. All Right? If they asked you for an average, then you would have used this. Okay. If they asked for a rate of change, then rather use the derivative because it's a rate of change, because we didn't have that option there.